I have drawn this simple layout to get us working on establishing signals on our layout. If you want to know how to do this or how I did it, I do have another little video on drawing layouts here on and with JMRI. But basically what I did was I added track segments between the green squares, two turnouts, one there and one there, and this sighting. These circles here tell you what this section of track is. So right click on that to tell you what it is, and I have named the blocks. I've divided this layout into blocks, and my blocks go from here around to here. That's one block. Block 1, block 1. All of these track sections, and they're not track sections, they're PanelPro layout editor track segments. So I have them all as part of one block. This is block 2. This is block 3. This is block turnout 2 and block turnout 1. What we need to do next is put some sensors onto and into these blocks. We need sensors to enable signal lights to know what's going on the layout. The way we do that, put our sensors in, is we go to Tools, Tables. Well, let me just show you what I've got already. I can't remember if this has been done previously or not. Those are the two turnouts. Notice here we have all the tables available to us, and we're going to be using turnouts, blocks. We've already established our blocks. IB means the internal block, and I put the number in, and JMRI put the IB, and I've named them block 1, block 2, etc. here. Sensors. There are no sensors. What I'm going to do is I'm going to put sensors in each of these blocks, one sensor in each block, and I'm going to use the same name as the blocks. Sensors. So we'll add hardware address, local net sensor 1, block 1. Okay, what we need to do then is just put 1 there. Let's see if that works. Okay, it did. And for the two turnouts, okay, that's that. Now, get back to this diagram, and we will put those sensors on the diagram this way. we go here, sensor icon. Let's try LS1, see what that does. And that's for block 1, shift, left click. Oh, it liked it. So I think we could have put the name in there. Let's try that. Block 2. This is block 2. Put the sensor, shift, left click. It liked it either way. Okay, block 3 up here. Turnout 1. And turnout 2. Red means occupied, and that's the way it comes up when you set them on here. So to unoccupy the block, you just left click on the little red dots. I'm going to walk through the installation on this layout diagram of signal lights, one set for each of the turnouts. I'm going to walk through the installation of signal lights using SCHC signal controller board from Digitrax, and on this other turnout I'm going to set out some virtual signal lights. Virtual signal lights are good to have on your layout diagram if you have turnouts or blocks that you want to control with JMRI signal light logics, but you don't have the actual signal lights. And in my case, on my layout, I have 4 turnouts that are inaccessible, that are controlling staging tracks underneath part of my layout. So virtual signal lights would be advantageous there, because Logix is able to control the whole layout, all the signal lights, whether they're virtual or actual physical. And you want that. So let's put some SCHC signal lights here. Before we do that, I want to take you to the instruction sheet that comes with the SCHC board to show you, introduce to you how SCHC works things. Here we have a turnout. SCHC allows us to have up to 4 heads. These are heads. 1, 2. This one has to do with the train going on the main line through the turnout. This one has to do with the train going onto the siding through this turnout. And these 2 have to do with trains going the other way through the turnout. What SCHC does is it gives turnout addresses to its signal lights. For example, the A1 head, which is this one, there are 2 turnout switch addresses, numbers 257 and 258. And what this allows you to do is to use your throttle. So if you have your lights set up and you go onto your throttle and you push the switch button and type in 257 and you throw it, the light will go red. If you close it, the light will go green on this head here. Well, that's fine. The only thing is you have all these numbers, this for that head and these for that head and the other 2 heads. So you have a lot of button pushing to make these things work manually. We don't want to do that. we want to do it automatically using the logics of JMRI. So here we go. What we need to do is to go to our table for signal heads. And we need to add. By default it comes up to double output, which we don't want. We are going to go to SCHC 4 aspect. We're going to give it a name. This is for the top head, which will be here. Let's try a name here. Let's go turnout 1 A1. Turnout number. Oh, we don't have any existing. No, that doesn't help. No, that's not what we want. Remember those numbers? Those two numbers will go in here. So we create new, we put the number in, 257, 258, okay. And it puts it in the table here and gives it this name. That's A1. Now let's do A2. Create new, and it'll be 259 and 260. And then B. And C. Okay. Now we want to put them here. So what we do is we go to here, signal head icon, and we type in the name, and the name must be exactly as it is in the table. Shift left click. Thank you. These two are pointing the wrong way. We'll flip them in a bit. They're dark. That's the way they come up. If you click on here, it'll go to red, and correspondingly here it'll go red. You can click on these and it'll take you through the colors that are available. Okay, for now, let's turn these around. Right click. You can either go orthogonal which moves them 90 degrees at a time. Or you can go degrees. They're not doing anything yet. That's because we haven't set up the logic for it. We'll set up the logic after we put these on here. To set the signals, here we could do the same sort of thing. We could go into that table. Well, we'll be going into that table anyway, but here's one way to do it. We can right-click on that circle and go down to Set Signals, and it brings up this little menu. We're going to have to put some kind of a name in each of these white blocks. Throat continuing is here, and throat diverging is also here. This is what they call the upper head, comparable to this one, and diverging is the lower head on this side of the turnout. And continuing here is the light that will go there, and diverging is the light that will go there. But we have to put some names in the table. So signal heads, and we add double output. No, we're going to virtual now. So it comes up with a different menu. The system name. It has to be I for internal, H for head, and I'm going to call it LT2 because that's the name of the turnout, and this is going to be upper. And this will be username turnout. To upper. And then lower. And then main. And sighting. Now these we will put in here, but they do put them in alphabetical order. So U will go here, L, M, and S. Now we'll just click these, move that out of the way, and click Done. Voila, puts them there. We'll put this on the right side of the track. It's for trains going this way. So again, we can click on them, go through 3 colors anyway. No, it goes through all of them, a whole bunch of them. And we can click on here and find out that as with here, nothing happens here. That's because the logic has not been set up. So now we're going to set up the logic, which will allow these lights to control trains in the blocks, LS1, LS2, LS3. It will allow these signals to take into account what's happening down here with these signal lights. It will hook them all together. We'll start with this one. Right click, edit the logic. I must get this right. It's on the main leg of the turnout. Remember, the top one controls the main line. First thing we'll do is we'll put in the turnout number. It's LT1. And if we apply that, we will see what happens here. Red and green. That's good. Might as well do it all right now. Sensors. These signals have to do with the sensor in the next block ahead of it, which is this one. So if we put in LS2, and then what signal does it protect? It protects the same equivalent signal in the same direction in the next block. So it's going to have to do with a signal that controls the main line, which is this one. IHLT2M. And if we've done it right and we click apply, it won't make any fuss. If we do it wrong, it'll spit it out and say doesn't work or something like that. This one is on the controls the diverging leg of the turnout. Again, we'll go to this one, LT1, apply. Yep. And the sensor would be the sensor on the block that it's looking after, which is this one. That's LS3. And the signal that this one protects would be this one. Let's see if that's right. Must be. Okay, that's those two. Let's do this one now. Edit logic. It's on the main leg. It protects the sensor in the next block. This is for a train going like this. And when it goes into here, this is the block, LS1. Turnout is LT1. Protect signal. Well, in this case, this will protect the next signal, which is this one. IHLT2U upper. IHLT2 upper. And this one is going to protect this one. IHLT2L. That's the logic for these. We'll play around just a bit after we get this all established. Now this one, we can right click on this, set signals, unclick, because we've already added them, and set up the logic all in one fell swoop. And it doesn't like that. It thinks that we haven't established the definitions for these. I thought we did. So in that case, I'm going to right click on this, edit the logic, just for the single head. Protect sensors. LS2 sensor in the next block. Red when the turnout is thrown, and it is LT2, and it protects this signal, turnout 1B. Turnout 2 upper. Go to turnout 2 lower, right click, edit logic. It's looking after the diverging leg. Protect sensor, LS3. Turnout is LT2, and the signal is this one. I have a terrible memory. Two more. Right click, edit logic. Main leg, protect sensors. Sensor in the next block is this one, LS1. Turnout LT2. And the signal for this one would be the signal in the next block that corresponds to it, and it will be this yellow fellow, turnout 1, A2. It should be A1. Hopefully last. LS1, the next block sensor, LT2, and the signal will be the signal. See, this sometimes lies to you if you haven't connected. This is turnout 1, A2. Didn't spit anything out at us, so now let's just briefly play around with this. Let's put the turnouts closed. 1 closed, 2 closed. These lights tell us for a train going to the right, you are clear to go. And when you get to here, you are still clear to go. And if you're going the other way, when you come to this turnout, you are clear to go, and you're still clear to go. And if we go to the sidings, then this one has to do with the siding, and it says you're clear to go both ways. What if there's a train here? What can it do? Oh, this one turned to yellow. What this says to us, or says to the train that is traveling in this direction in this block, when you get here, the yellow says slow down because the next signal that you will encounter will be red. Be prepared to stop. Same in this direction. If there happens to be a train in that block, then this will go to red. You cannot go from this block to this block. It's occupied. And because these signals are protected, if a train is coming along here and it wants to go onto the siding, again, yellow says next light will be red, and it's red. And if a train is going this direction and it comes to this turnout, this tells the train that you cannot go into the siding because of the way the turnout is thrown. It's closed. But if you want to go on the main line, you are free to do that. However, be prepared to stop, because the next light will be red. And there it is. And of course it's red because the turnout has been thrown. If we close it, we're back to green. It's a lot of fun to play with on the diagram. The next step will be to go on to the layout and actually set up these signals to be connected to the SCHC and the LocalNet system on our actual railroad. So we'll be doing a little bit of a video on how to move this to real life on our layout. Thanks for watching.